Yo, what's up, YouTube? It's Cracker Tombere. Got back. I just woke up. Got to have physics assignment to do within 1 hour. You heard it right, 1 fucking hour. So let's get into it, shall we? Shall we? Got the small stuff and got rid of the big stuff. Now get the card. Oh shit! It's resistance. It's actually pretty. It looks pretty easy. No, this guy's dead. Don't tell me this guy dead. I should have noticed. The tablet going off. Come on. That's the worst timing. Monday. Monday morning. The week starts just like every time. It still got 13%. What the, what the hell? Mm-hmm. Physics 2 for biological chemistry. No. So what's the first question? Why is the electric current through two resistors in the series same? Electric Ohm's law. In a series circuit, there's only one path for the current to flow. Therefore, the same current must pass through each resistor connected in series. This is a consequence of Kirchhoff's law, Kirchhoff's current law, which states that the current, current entering a junction must equal the current leaving. In a series connection, there is no junctions, so the current must remain equal throughout. That's the first. Why is the voltage through two resistors in parallel the same? In parallel circuit, the resistors are connected across same 2 points, meaning they share same potential difference across them. This is a consequence of Kirchhoff's voltage law, Kirchhoff's current law, which states that the sum of the voltages around any closed loop must be zero. In parallel, each resistor forms its own loop with the voltage source, so voltage across each resistor is equal to voltage source. When is power source a constant current source? When a constant voltage source? When is a power source a constant current source? when a constant voltage source. A power source acts as constant voltage source when it maintains a fixed voltage across its terminals regarding of the load resistance within its operational limits. Example include batteries and regulated power supply. A power supply acts as constant current source when it delivers a fixed current regardless of the load resistance. These are less common but are used in applications like LED drivers or blasting circuits. What? Okay, don't care right now. First problem: a battery consisting of the unknown open circuit voltage U0 and an unknown internal resistance is connected in a series within the circuit using an ampemeter as an unknown resistance and an additional resistance R1. The following observations were made. The short circuit current measured when the battery terminals are directly shorted with negligible resistance bypassing any circuit elements. When adding R into circuit, the ampere meter measures a current of 1 ampere. When resistance R is added in a series R1, the ampere meter measures a current of I2. Okay, just 2.25 ampere. With this information, determine the open circuit voltage U0, the internal resistance R1 of the battery, the resistance of R. Okay, open circuit voltage U0. I still don't understand the circuit. I believe we got series resistors. The short circuit is given by the current in the short circuit is given by voltage by resistance. Total resistance is product of what? Fucking stop, bro. It's 8. Got 1 hour. Got 1 fucking hour. Oh. The current with R and R1 is 27 ohms. In series, I2 is 0.25 ampere. U0 is I09 into R1. I1 is U0 by R plus. We need another equation to solve U0 when R is added. Okay, 1 ampere, 27, right? This one's 27. R is 8 Ri. Okay. When R is added in series with R, so 8R, 9, 10R, 10R. Mm. God, need some water. What we gotta do here, so that's the first internal resistance Ri. From the above calculations, we could say that Ri is 1 ohm. Answer. That's it. Okay. Resistance R. R is 8 R. Okay. 8 ohms. Okay, Bob. Question one is done. Gotta just write these stuff. No snow. I hope I don't get called today. No, I don't think I can do a presentation just from copying the short circuit current. Just write first write math results of. Gotta be kidding me. Short circuit current ISC equals 9 ampere current with R in the circuit. I1 equals 1 ampere current with R and R1 in series. So that's I2. Yeah, that's I2. It's a 0.5 ampere. And the first part, what if it's an open circuit voltage U0? Open circuit voltage U0. If first of all, open circuit means no current is flowing, if I understand. Don't make sense, but yeah, I can't keep writing. Uh, Short circuit current ISC equals U0 by Ri. That's the short circuit resistance, I believe. Or that's the resistance of okay, I believe that's the resistance, internal resistance of the battery. An unknown resistance and an additional resistance. Yeah. Battery consuming and an unknown internal resistance Ri. So that's the unknown internal resistance. Known internal resistance of battery. And the U0 is okay, so open circuit voltage is short circuit current into internal resistance, unknown internal resistance, which gives 9 times unknown internal resistance. That's equation number 1. And now we gotta now current with R in the circuit. I1 equals U0 by Ri plus R, which is 1 ampere. So 9 Ri by Ri plus R equals 1. So R equals 8 Ri. So what is this new R? That's the it's connected in the series within the circuit using an ampemeter and a known resistance R. Okay, so other than the internal resistance of the battery, there is an unknown resistance outside the battery of this in the circuit, I believe. Yeah. Yep. So, oh yeah. So that's that's the outside unknown resistance in the circuit. Now, when current with R current with R and R1 in the circuit. I2 equals U0 by Ri plus R plus R1, which gives 0.25 amperes. And after calc, which is 9 Ri by 9 Ri plus R1 equals 0.25. No, it's 27. Fucking idiot. 27, yeah. And internal resistance, the unknown internal resistance of the battery is 1 ohm. Fuck yeah. And the uh, open circuit voltage is 9 times 1, which is 9 volt. Oh, shit. Oh, we did it. Unknown internal resistance Ri of the battery equals 1 ohm. And part AB, well, that was B. Okay. We gotta do D. Come on, D. C, not D, C. The time, it's 11 minutes. It's past 11 minutes. Hey Siri, set a timer for 30 minutes. The resistance R. What is that resistance? That's the unknown. Eight times internal resistance of the battery, which is 8 ohm. Oh shit. So that first question is done. I know it's easy, but I never thought it was this easy. No. So, in order to supply power to a heating element with resistance R3 as constant as possible, the circuit given in Figure 1 is used. What is the electoral power P3 dissipated by the resistance R3 as a function of R1 and R2, R1, R2, and R3? Okay. Now that's something I can do. For which value of R3 is P3 at maximum value? Mm-hmm. Mm-hmm. So power P3 dissipated by R3. Okay, I'll explain the figure. I can't type. Parallel. Parallel. Yeah. Come on, think fast, bro. R1 is connected in a series. Okay. You figuring things out? So what formula did you use the last time? Power P3 dissipated by R3, R total is equal to R1 plus. Oh, I mean, that's it. You figured it out, son. Okay, those just assumed. I mean, that's good. Good assumptions. The voltage across the parallel combination is. Mm-hmm. Mm-hmm. P3. What's the second? For which value of R3 as a function of R2 and R1 is P3 at the maximum? I mean, I don't know. Okay, so I believe P3 is same, right? U0 R. Okay. There's the difference. R1, R2, R1, R3, R1, R2. Okay, I think that's the answer. Come on. R1, R2, R1, R2. Okay. Yep. That's correct. I just gotta write it. First, let me draw the figure. Point A goes to R1. R1 connects series to R2, R3. Maybe I have to present this on class. I mean, I could do it, bro. I could do it. Okay. R2, R3. Power P3 dissipated by R3. Idiot. You don't know how to P3 dissipated by R3. Uh, plus P3, and R parallel is R2 R3 by R2 plus R3, and our total is total equals R1 plus R2 R3 by R2 plus R3. Total current I equals U0 by R total. What is U0 by R total? Voltage across the parallel combination. So, voltage across the parallel combination is this is the current across the parallel combination by total resistance. But how is this equation equals this? R parallel. This is the total resistance. How? I don't. I didn't. Oh. Voltage drop across R1. The current I flows through R1, causing a voltage drop, and the drop in voltage is this voltage across the parallel combination. Since distributed across R1 and parallel combination, the remaining voltage must appear R2 R3. U0 minus VR1 minus V parallel is 0. U0 is VR plus, okay. Okay, so yeah. U0 equals V parallel plus V series. I believe ChatGPT. I'm gonna need some assistance. V1 plus V2, okay. So that's the Ohm's law. And we have to find we have to find these, we have to find V parallel. So V parallel equals U0 minus V series, okay? Okay. I see it. Which is okay. I into R1. But we can also express V parallel Directly using the current I and equivalent parallel resistance. Yeah, yeah, I mean, yeah, you could do that. V parallel equals I into R2, R3 by R2 plus R3. You could do that, yeah. Find final expression for V. The I is U0 by, oh, I see it now. I see it. You could cancel those. R2, okay. Okay. So V parallel equals I into R parallel. Just U0 by R1 plus. Yo, Masonic 12. What's up, man? I've seen your comments. Respect. I really respect for commenting. I think you are one of the first few comments in this channel. Yeah, I'm here doing my physics assignment, which I have to submit within 36 minutes. I think you're my favorite small YouTuber. Respect, man. I mean, YouTuber. Yeah, I would say that. It's like it's a daily challenge to keep studying. Respect that. What are you up to, Masonic 12? What are you doing right now? R2 R3 by R2 plus 3 R3 into R2 R3 by R2 plus R3. I believe I'm audible. You could hear me, right? Oh, I think it's typing it. Oh, baby. Yeah. So we parallel the voltage across the parallel resistors. We still got after getting V parallel, and we have to find the power. Let's explain the V parallel situation. After getting V parallel, I think you could calculate. Oh, I still haven't wrote the equation for power. Voltage across parallel combination R2 and R3. Uh, P3 is V squared parallel by R3. R3, okay. Uh, what's the formula for power dissipated? Sis resistor, small resistor. Yo, Masonic, what are you up to, man? Mm, voltage. If you know current through the resistor, power is current square into resistor. Okay, or if you know, to calculate power, we have two ways we could calculate power. If we know the current through the if you know the current through the resistor, if you know the current through the resistor, you could do this, right? It's I2 into R3. Yeah. Or you could do with voltage V parallel square by R. That is the that is the resistance. Okay. Okay. And I chose the voltage for formula. Okay, V parallel is, oh, I don't want to calculate this, man. I should do it. U0 R2 R3 by R1 into R2 plus R3 plus R2 R3. Yep, that's V parallel. Now, power dissipated is V parallel square by the resistance. So, no resistance, it's just resistance. There's no exponent for the resistance. So, what would be B? U0, so it's U0 R2 U0 square R2 square R3 by, oh man, R1 into R2 plus R3 plus R2 R3 whole square as the power. So power dissipated. Okay. Now for which value of R3 as a function of R2 and R1 is P3 at the maximum? Well, we'll let P3 equals by D, where D is differentiate P3 with respect to R3. Okay. We gotta use differentiation. Substitute D. Solve for R3. R3 is R1, R2, R1 plus R2. I mean, gotta be better ways to do this. Hmm. So at which value of R3 will the power dissipation be at its maximum value? Yeah, I guess we gotta use differentiation. I mean, there's a R1 plus R. Okay, it's A plus B, A plus C plus B. Okay. Differentiate P3 with respect to R3. I mean, okay, I can do. So for the B part, P3 is U0 square R2 square R3 by D square. D or R R square, yeah. R square gives where D, R where R equals R1 R2 plus R2 R3 plus R1 R3, and differentiating this, come on, differentiate P3 fast P3 with respect to R3. D of P3 by R D of R3 equals using the quotient rule. Into D square minus R3 2D. No, R square minus R3 2R into R1 plus R2 by R raised to 4. Take the R out to simplify the numerators. I did not understand the last part. R1 plus R2 equals 0. Then D equals, no, R, fuck me. R equals square equals 2R R equals 2 times R3, R1 plus R2 R1, R3. In which we get R3 equals some. So R3, we get R3 equals the parallel connection of the two rest of the resistors. It's interesting. Oh, that way we could get the highest value of power dissipated by R3. Okay. Okay, I'm not arguing with that. I get it. I get it. I get it. So we done with the physics assignment. Oh man, that was fast. Oh. Of course, mate. I mean, yeah, I'm really happy that I could do it before the time. That's progress. Now I can play Last of P, 15 minutes Last of P, man. Can't wait to fail it. Can't wait for the boss to kick my account into, I don't know. Got my sign. I signed the, oh, let me let me show you the, I signed my answer. How do I show? Yeah, I signed the answer. So the professor, when when this person's reading, they know. Yeah, this is this guy. Okay. What did I name these assignments? Uh, Physics X9. No, 10. Time is 10. Okay. That's it. Mm-hmm. Moodle is already up here. It's good. That's good for me. Oh, yesterday, man. The last 2 days, I could not do shit. I was so fucking tired. Hangover, man. It was a hassle. But got stuff under control now. I believe I downloaded the application. Yeah. Um. Okay. Which is 2C? 3, 2. That was 2. In order to supply power, the circuit given figure 1 is used. What is the electrical power dissipated as a function? Yeah, there's only. Uh, I don't know. I don't know what's the confusion. I mean, there's some sort of confusion, I guess. Two people viewing this. It's already pretty scary.
Now it's time for lots of bit, lots of bit, lots of bit.
What would is this work? This application, IntelliG idea. So I think it's downloaded. I don't need to. Well, YouTube. Oh, YouTube stream cannot close. Well, I guess Twitch stream should be closed. I cannot download. Oh, I don't think LiceFP works together with both Twitch and YouTube. But we could try. We could try. Open, yeah. Uh, Import settings. Skip import. Paid license, activation cord, license server. First of all, I have a student stuff. I'm a student. No. Oh shit. Continue with the Apple GitHub. No. How do you get the student? Wait. IntelliG AI. You know what? Yeah, it runs, right? I'm gonna close it. I'll do it later. Exit. The problem now is I don't know if LiveCP will run when I'm streaming on both YouTube and Twitch. I usually stream on Twitch when the game is running because, it's not a powerful laptop. So uh, I believe the YouTube stream might crash. So people of YouTube watching right now, I'm sorry. You could check the yeah, you could check the gameplay on Twitch. See ya, YouTube. I'm gonna have to take it down.